So let's take a look at an example here. On this first example, we have a simple random sample of 13 four-cylinder cars. And we're looking at the data for those. For that group, the mean has a braking distance of 137.5 feet and a standard deviation of 5.8 feet. So that's our first group of information. So let me go ahead and translate that. So we have our first group. Let's call that group 1. And they gave us, let's see, the size of the sample there, or N1, is 13. What else did they tell us? They told us our mean, that's the X bar, and again, this is our first group, so let's call it X bar 1, is 137.5. And for the same group, we have a standard deviation of 5.8, so we'll call that SX1. And because it's, again, we're using S because it's for a sample, remember they use the word sample, is 5.8. Now, so 5.8. Let's look at group 2. And that should be what's coming after this. Okay, group 2. The second set of information is about a simple random sample of 12 six-cylinder cars, and it's obtained, and the braking distances have a mean of 136.3 feet and a standard deviation of 9.7 feet. So let's translate this. For our second group, the number in this sample is 12. The mean for the second sample is, well, they say there's a mean of 136.3. And the standard deviation, the SX2, for this sample is 9.7. Okay, that's almost everything. Let's see what else they tell us. They also tell us that our significance level, our alpha, is 0.05. So let's go ahead and write that off to the side. And let's see, what else do they tell us? We need a claim somewhere. So our claim is that the mean braking distance for the four-cylinder cars is greater than the mean braking distance for the six-cylinder cars. Remember, we did our four cylinders first, that was our group 1. And we did our six-cylinder cars second, that was our group 2. So that means we're gonna, let's see, and in our claim they mentioned the four cylinders first and our six cylinders second. Four cylinders first and six cylinders second. So that means we're talking about the mean or population mean of the first group, the four cylinders first, and the mean for the six cylinders second. And they said that the four cylinders was greater than the six cylinders, so we'll use the greater than symbol. That is our claim. Okay, now we can continue right along and do our p-values approach. But we have to start out by figuring out where this claim lands. Well, because our claim had a greater than symbol, that will put it as our alternative hypothesis. Because it didn't have an equal to, it will land as our H1, which means the null hypothesis will be the opposite, the complement, which will mean it'll have a less than or equal to. Now, you can run your 2 Samp T-Test. So let's see what we're going to plug into our 2 Samp T-Test. Well, remember our 2 Samp T-Test, we're going to take all the information from group 1, which was that our sample size was 13, the mean was 137.5, and our standard deviation was 5.8. So that's all this first set of information here. Then our second group had, let's see, a sample size of 12. Let's see, a sample mean of 136.3 and a standard deviation of 9.7. So we'd plug all this information into our 2 Samp T-Test. And again, remember that this is just a bunch of statistics. We don't have lists of data, so that's how you get to this screen. And then if you continuing arrowing down, remember we're going to use what was in our alternative hypothesis to tell it what kind of tailed test. So because there was a greater than in our alternative, that's what we'll choose, a greater than symbol. Remember, we automatically leave the pooled as no, and then we will select calculate at the bottom. Once we select calculate, let's see what happens. It's going to run our right-tailed test, and here's what our results will spit out, is it will spit out a t-value and a p-value. Because we're only going to do the p-values approach, we only care about that. Let's narrow in on just the p-value. Remember, it was a right-tailed test, so that will be the area in our right tail generated by the t they listed. So if you did want to put that t somewhere, you could put it on your picture that made your p-value. Okay, so we have a right-tailed test. That's where our p-value fits, and the t created that area, that p-value, the area in the tail. And continuing right along, then we'd say, okay, now that we have our p, we ask our same question we always ask, is p less than or equal to alpha? Well, we found out our p was 0.36. That was our p-value from our picture. And our alpha was given in the original problem was 0.05. So is your p-value less than alpha? Absolutely not. No. Okay, then the question is, what does this mean? Well, I need to rewrite my H naught and my H1 to figure out what this actually means. Well, remember H naught was that the mean of the first one, the 4 cylinders, was less than or equal to the mean of the 6 cylinders, the second group. And our H1 was that the mean was greater than the mean for the second group, and that one was our actual claim. So remember, if we say that our answer is no for when p is less than or equal to alpha, what does that mean? Remember, a no means that you're going to fail to reject H naught. So let's write that out. So we're going to fail to reject H naught. Problem. That is the one I don't really care about because that's not my claim. I actually care about the other one. Well, that's going to be the complement. So if I'm failing to reject the null hypothesis, I'm going to do the opposite. I'm going to fail to switch it around, fail to accept the alternative. So let's see. I'm going to fail to accept the alternative. I'm going to do the opposite. I'm still failing to, but I'm failing to accept. And the reason why I care about this one is because that one's the one that's my claim. So I'm failing to, there was a typo here, accept our alternative, our H1. So what does this mean? Well, remember, if I'm failing to do something, that means if I'm failing to do it, it means there wasn't enough evidence for me to actually do anything. So failing to means that there was insufficient evidence to, again, there was a typo on this one, to what? To accept the claim, because my claim is the alternative hypothesis. So there is insufficient evidence to accept the claim that the mean for the 4 cylinders was greater than the mean for the 6 cylinders. And we're done. And again, like we stated at the beginning, we are only going to do the p-values approach for these. We will not do rejection regions.